Hello, everybody. I'm Joel Cámara. He's Hernán Wilkinson. Oh, sorry. Okay, Hernán, Joel. It's always a bad joke. We're going to talk about a little bit about refactorings in Cuis. As you know, mostly refactorings in Cuis have been made by people doing their thesis, and this is not the exception. But I want to start. ¿Me tenés? Showing some of the small things that other students have done. Oops, here. So last year we presented the struct class, move method, and move instance variable, work done by Maxi Cabezon, and he made some improvements to those refactorings that I want to show. One of them is to move a method directly to a class. We don't need to move it. We don't have to use an instance variable as a reference for the class, for the method to move. So right now, we can just say, okay, move this method to you don't have refactoring apply move method. Chang. Okay. Let's do something. Whoops. Next. Or my mind.
Well, I'm going to talk about two refactorings that exist now in Cuis, but I made some improvements. Here we have an extract variable, and we have we had we had this. Think about that code, and I want to extract 10 factorial, but the one that is returning here. So exist extracts temporary, and I can extract it, but we have a little problem. It doesn't tell you that exists another 10 factorial that is above, and that is not very good. It would be good that they tell you, hey, you want to refactor that also? You want to extract that piece of code? So what did I have to solve this? Well, I can have all the nodes and the code intervals of repeated code that comes from extract method that exists. Extract method can tell you in all the hierarchy all the pieces of code that are repeated. Define and declare a variable in a node. Okay, I have it because it's an extract variable. Here I can do that. Replace a piece of code with another. Also, it counts with extract variable. The problem was that I don't know which is the node that I have to, in the AST, that I have to define and declare that variable. That is the problem. Have a question? That's a good question. We don't know. Yes, we don't know.
That depends on the program. If that side effect, if the message got side effect, you don't know.
Yes. Okay, sorry. And well, the problem is that I need to find the node in the AST and the code interval also to define and declare the variable. And let's see some code here. I really have the code. Ay. What did I do to find it? I didn't use the complete AST. I did something a bit different working with AST, but I found out this is the method node. The method node is the one that is the root of the AST, and I can ask things to the method node, like the parse nodes that are in that place in the code. And that 6 is this character. The problem here is that, yes, I can I can work with the AST, but at the end, I am changing strings and then compiling it. So I need to work with the intervals. So if I have this and I inspect it, I get a collection with all the nodes and their intervals in the code. Here we have the 10, that is this 10, and the 10 factorial, that is this one. So with this, I can get all the nodes that are involved in the piece that I'm trying to extract, the piece of code I'm trying to extract. So how was the algorithm? It was pretty fast to solve at the end. It took me a couple of months to realize that it was this easy. But for each piece of code, to find that node, I put all of these nodes in a set, and I intersect all of them. So I get that all the nodes that have the common scope of that pieces of code. Let's So if I have one is that, if I have none is the method node. Here you can see that this doesn't return the method node, so it's kind of a callback. Here I can use the method node that I have it, or if I have more than one, I can use I choose to use the the one that is nearer. And let me show you some examples. If I want to extract this 10 factorial, now it, it would do something like this. It's a temporary bar. It shows you this window that says, hey, there is repeated code. This window is like the one that is used in extract method right now. So I changed it a little bit just to show the similar code, but just in this method. And I can extract the original selection only or the ones that are in this list. So if I put refactor, I extract the variable here. I define in this node, and here are the replace code. Then this works also with blocks like this. I can extract this one. If I extract this piece of code, the temporary, I factor, and it works. The common scope of these two blocks is the method node, but this works also with the block. Uh, Here we have in that block was made. And then we have this kind of thing that was something difficult to realize until before this talk. I thought it like yesterday or the day before. This kind of code, it was difficult because I have more than one scope to choose where to add the new temporary. And as I said, this will refactor it in the common scope that is more near or nearer than the pieces of code I'm trying to extract. But the future work here is that someone had to do it. that let the developer choose where is the scope where he wants to define and declare the variable, the new variable. And this is the extract to temporary variable. He didn't like the at the very beginning. He didn't like the solution because he want me to work with the AST and go through all the nodes and find the node that I want. But I couldn't do that because when you are in a node, you don't know where you came from. So there is no way up to now. Someone has to do it. A new thesis. I'm not going to do that. But there is no way to know where you came from. So if you have this piece of code, let's say that there are 10 factorial and 10 factorial and this dot. The AST runs like this one and this one and this one and then this one, but doesn't say if you are inside the block or not. So that's a problem that someone has to solve it. And then I've been working on well, this is the future work and change keyword selector. This has a bug, or had a bug, but at least it's not integrated to up to now. But this has a bug, and it was really funny bug. Reorder keywords. Let's see. We have this piece of code. I want to concat with another string, a string with another string. So yes, we can change the keyword order, but when you change the keyword order, the senders doesn't change the arguments. That's a bug, a funny bug that you don't want to know, that you don't want to have. So I have this was almost done, but I have everything. I have all the senders. I have the change in order. I have the nodes that are changing, but I didn't have the arguments positions. So I did something similar to the extract temporary. I can get the node. I have the intervals of the keywords, the keywords. So the ones that are in the middle are the arguments. So I took them, and it was easy to replace them because I have the change in order. So right now, if I have the sender here, if I do this, I change the keyword order with concat class. Yes, factor. This changes with another string, concat the string, and here the sender changes the also the arguments that was missing. Then I have another examples. I have this one, M1, M2. This is pretty similar with the previous one. It doesn't matter the amount of elements because I just took an interval from the string. But also I did something because this is a refactor and some people want to work, I don't know, I don't know why, like this. Let's see, you have this kind of things. And if I want to refactor that, M33, M22, M11 class refactor, and you see another sender, it will changes also the spaces they have. They keep the spaces it has, trying to not to bother or to change too much the style of the programmer. The future work of this one will be to integrate reorder keywords with rename. with rename selector and let the developer choose what he or she wanted to do. If you want to rename, change the positions of the selector, etc. That would be a nice future work. But now works. This has a bug. And I have nothing more.
Okay.
I think
Continue.
up to now.
Okay.
He will continue.
Okay, thank you. There is one more thing that you're doing that you didn't mention that he has to do, and that is the struct method with parameters. So look for repeated code, but with places that can be parameterized. So if not, you're not gonna, how do you say this? No vas a probar la tesis. Uh, that's how I treat students. I don't know how big this is. Oh, okay. Okay. As you see, we like the factorial message. That's why we use all the examples. And that's so I was going to show this feature of the move method refactoring that allows you to move a method to a class instead of going through an instance variable. So now, for example, this method, you can move it directly uh, to a class. And you can select the class. For example, I'm going to select target class. And as we can see now in the in the class side of target class is this new method that in this case is receiving the instance of refactoring examples, blah, 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 because the original method was returning self. So to keep the same return, to return the same object, we have to pass it and then return it. In this example, I wasn't referencing self, as you saw. It was just 20 factorial. But it also works when you're referencing self or instance variables or wherever in the method. It does all the same things we showed last year, well, Maxi showed last year in the conference. But I want to show that it also works when you are referencing self explicitly. Let's send it also to target class. And here it is. I don't know why the so sorry, you can move it to a class and you can also move it to a global object. Okay, it's the same thing. It will move it to the class of the global object. The other thing I wanted to show is work done by Marcelo. It's the struct parameter object. I talked about it last year, but now I'm going to show it. And the idea of the struct parameter object is that you can select some parameters from the message and extract them to a class and replace all the senders with the instantiation of that class with those parameters. So, for example, in this case, I'm going to extract first and third to a class, and you will see that the sender here, we will send a message with a new instance of that extracted class using 1 and 3 as a parameter. So let's do it. It's a very interesting um, refactoring. This is not done with a GUI designer. That's why it doesn't look very nice. Well, you will know what it is tomorrow. So here I will select first and third the parameters I want to extract, and the name of the class, let's call it first and third, the superclass and refactor. If he, and then it will ask you for the scope of the refactoring, of course, because you have to look for implementers and senders. Like all the refactorings that needs to look for implementers and senders will ask you for the scope, and of course, if you have live typing implement install, it will allow you to use the actual scope. I'm going to use just the class as a scope. So we see here the implementors, the sender is going to change. And if we refactor, there's a new class, FT, with an instance creation message that receives first and third. In this case, it's using the same keywords that happens to be the same as the parameter. Initialize the instance, and in this case, it only implements the getters for first and third because we are not changing those objects in the code that we're extracting. And in the case of the sender, it will send, well, the message was renamed to, in this case, keyword 2, and the name of the class, okay? And as you can see, we keep the same behavior, getting the first of that object and the third, sending the message third to that object too, that is instantiated using the new class and the instance creation message. So it's very useful when you have parameters that you pass all the time on different messages, so you can extract those parameters in one class. Then we fix some bugs we had in the struct method, most of them related to extracting blocks or assignments inside blocks or assigning assignments to variables and so on. This is something that's not going to be maybe new for you, but it didn't work before. So now you can extract a block that is repeated on different methods, like this one. It is here, 10 factorial, and here we have two of those, two. So I can extract that, do a method, the extract method. I don't know, let's call it 10 factorial, and it will extract the three of them. As I said, this works perfectly fine when there were not blocks, and now it works correctly with blocks. So we have 10 factorial that returns the block and all the extracted code. Okay, so you have to look. We got to continue in your machine. Okay, so that's a very interesting refactoring. The other one that it's in the list is to encapsulate instance variables. That's a pretty easy one. We want to improve the move method to inline the original method or keep it. Right now, it just keep it. And also, when doing a move method, to show you the methods that are dependent that method is using. So to ask you if you want to move those methods too. We want to improve the struct class to minimize the number of getters and setters that are currently created. And we also want to start improving a little bit the auto-completion. This is not a refactoring, but it's an interesting to not just look for the selectors when you autocomplete, but also for the name of the parameters that are expecting that can give you a clue of a better clue of what the message is expecting, but also to combine that with type information, with live typing, to allow you to see the options for those parameters. The instance variables that you can use or the local variables that you can use as parameters because are of the same type, as an example. So those are things that are in the to-do list. And I think that's all, isn't it? Yeah, thank you.
When you change the order of the keywords, you in all examples you use the same keywords but in different order. Do you have to preserve that, or you can just use a different selector?
No, you have to preserve those.
Okay.
It's not a rename, it's just reordering.
That's why it is a future work to integrate it with rename.
Okay.
Yeah, there is a problem if you try to rename them while changing them. I don't remember what was the problem, but there was an issue. I don't remember right now which one was. Okay.
Just an observation that kind of a master's level or even a thesis level examination of proving whether our arbitrary code is a transformation or not. Right? We have simulation facilities in the system, so you can execute bytecode and things, and you can execute bytecode with a timeout,
Mhm.
right? So that you only expound a second or 10 seconds trying to prove, but you can do things like mark every object in the system which doesn't need to be
Mhm.
mutable. So, for example, the process the schedule processes do need to be mutable, right? But things like the instance variable array in a class doesn't need to be mutable, etc. So
Mhm.
if you were to mark most of the objects in the system as immutable or read-only, and then execute the code that
Simulated.
you want, you could do things like, track the set of instances in this evaluation of 10 factorial, and then do a second one and check that the two are distinct sets and things. So there's all sorts of analysis, semantic analysis that you can do through simulation to actually prove
Yeah.
whether or not a piece of code can be transformed. And Juan mentioned that one of the things that Cuis and Squeak, the Smalltalk really needs is things like a parallel collect. And being able to parallelize collect depends at least on proving that the block that you use to collect doesn't have side effects. And again, this is the kind of thing that can be verified by using simulation. So one of the the underlying thesis topic that would enable lots of
Mhm.
other things is kind of a more generic semantic analysis of the execution of a piece of code.
Mhm. Yeah. Thank you. Yeah. Okay. Thank you very much.